Today, I'm going to reveal why our human-centric approach to AI detection might be causing us to miss true artificial general intelligence happening right under our noses. Drawing from ancient wisdom to modern science, I'll show you the crucial signs of AGI that nobody's talking about and why they matter more than any Turing test. I'm Evan Goldstein. I'm a licensed professional engineer and a data scientist. I'm building the AI Capitalist channel to talk to the leaders and the thinkers, like you, about how to thrive in this new world of intelligent machines. In this episode, we're going to explore one of the most crucial questions facing humanity in the age of artificial intelligence. How will we recognize true artificial general intelligence when we encounter it? In a previous episode, we explored research on 14 telltale signs that our machine intelligence has achieved consciousness. Today, we're going to go deeper and look at some of humanity's previous attempts to grapple with alternative forms of intelligence and what we can learn from them. Rather than approaching the question in isolation, we're going to look back at humanity's long history of encountering and attempting to understand different forms of intelligence, from our relationship with divine intelligence across various religious traditions to our complex history of recognizing or failing to recognize intelligence in other human cultures, as well as our growing understanding of diverse forms of animal intelligence, and then finally to our theoretical frameworks for recognizing potential alien intelligence. Each of these encounters offers vital lessons and warnings as we stand on the brink of potentially creating or encountering artificial general intelligence. Through the examination of these historical and theoretical parallels, we aim to develop a more sophisticated and nuanced framework. The first type of intelligence I want to look at is divine intelligence. Now, I can already hear all the atheist Marxists and singularians clicking away, running out of the room. So let's just say I'm not trying to recruit you into my own or any other faith. But even if you aren't a believer in any faith, you can look at this as a human conception of what a superintelligence might look like. Remember that the divine eludes definition, but so do other transcendental concepts like time. Yet we still talk about those, and we have a common point of reference. I even made a video on how to teach AI to recognize and understand transcendental concepts. The thing with divinity is I can be standing and looking at some act or something happening either in history or in nature and say, oh my God, I'm blown away. This is proof of divine intelligence. The person standing next to me might be looking at me like I'm crazy and saying, no, it's just molecules moving around. This is true with any transcendental concept, right? What is consciousness? The person next to me might have a completely different understanding of that, and I think there might be people in this world who don't qualify as conscious. So throughout human history, our conception of divine intelligence has represented the ultimate form of wisdom and understanding, a type of intelligence that transcends human limitations and comprehends all aspects of existence simultaneously. Divine intelligence is characterized by its completeness, its perfection, and paradoxically, its fundamental incomprehensibility to human minds. When humans encounter divine intelligence in religious and philosophical traditions, it's usually marked with a profound sense of awe and an acceptance of our own cognitive limitations. Divine intelligence is understood to operate on principles that may seem paradoxical or contradictory to human logic, but they're resolved at a higher level of understanding that humans can't fully grasp. The relationship between humans and divine intelligence is historically one of reverence, submission, and acceptance of mystery. Rather than attempting to fully comprehend divine intelligence, humans have traditionally sought to understand what aspects of it they can, while accepting that a lot of it remains beyond their grasp. This relationship has often been mediated through texts, prophets, and religious practices that provide glimpses of divine wisdom, while acknowledging its ultimate transcendence. When we consider artificial intelligence in light of our historical approach to divine intelligence, several important distinctions emerge. While AI systems might seem godlike in their ability to process vast amounts of information or make predictions, they fundamentally remain human creations, and they're bound by the limitations of their training and their programming. Now, I did make a video about how people are starting to believe the moral decisions made by chatbots and trust them to an even greater degree than they trust human moral decisions. This is, in my belief, a mistake, and this distinction becomes crucial when we consider the role of moral judgment. Divine intelligence has traditionally been viewed as the ultimate arbiter of moral truth and providing absolute standards of right and wrong that transcend human perspective. AI can only reflect and process the moral judgments that are encoded in its training data and its architecture. While AI might be able to help us reason about ethical questions or identify inconsistencies in our moral thinking, we can't rely on it as a source of moral truth in the way that religious traditions have looked at divine intelligence. AI is just a tool for moral reasoning rather than a source of moral authority. And this fundamental difference needs to inform how we approach and utilize AI systems when we make our ethical decisions. How do different religions interpret intelligence? Because religions hold different values, and they're looking at this from a very different perspective. The Jewish conception of divine intelligence is fascinating with its emphasis on divine wisdom being accessible through debate and interpretation. In Jewish tradition, divine intelligence isn't just handed down, but it's actively engaged with through the practice of pilpul, which is Talmudic debate, and through midrash, which are interpretive discussions. There's a famous story in the Talmud where the rabbis are debating a point of law, and Rabbi Yoshua is arguing with a board of rabbis, and he says, if the walls collapse, or if the walls bend in, then I'm right. And the walls bend in. The board of rabbis says, no, we still disagree. And then it goes through a series like this until a voice from heaven says, Rabbi Yoshua is right, you got to listen to him. And then the rabbis say, it's not in heaven. In other words, the idea is that divine intelligence has been transmitted to earth, and it's up to us to work within it, and our decisions hold value. So it means that divine wisdom, once given through human, is meant to be understood through human reasoning and debate. Islamic conceptions of divine intelligence emphasize absolute unity, or tawheed, ultimate inscrutability. They believe that Allah's wisdom can be glimpsed through the Quran and through the natural world, with a strong emphasis that divine intelligence operates on a level fundamentally beyond human comprehension. And this is reflected in the Islamic tradition of describing Allah through negation, defining divine attributes through what they are not rather than what they are. I should mention that this is also a Jewish interpretation. You can only say that God is infinite. You can't pin down, we say we pray to him, but there's also a her side of God. You can't say him or her, it's this or that, or even those two are limiting. And so all we say is that God is infinite, and you can't say anything else. Christian traditions have generally conceived of divine intelligence as more directly knowable through Jesus as the incarnate logos, the divine reason, while still maintaining its ultimate mystery. And this creates an interesting tension in Christian theology wherein divine intelligence is seen as something that became human and walked among humans, while simultaneously remaining transcendent and beyond human understanding. In more Eastern traditions, like Buddhist conceptions of ultimate wisdom, differ because they don't personify it. The Buddha nature, or the Dharmakaya, represents a kind of universal intelligence, or wisdom that isn't separate from reality itself. Rather than being an external divine mind, it's an awakened state of potentially accessible to all human beings. Hindu traditions have multiple perspectives. The concept of a Brahman as the ultimate reality encompasses all intelligence and consciousness, while different deities represent different aspects and manifestations of divine intelligence. Now, Taoists believe in the ultimate wisdom and emphasize its ineffability. The Tao can be spoken is not the eternal Tao. It suggests a form of intelligence that operates through natural principles rather than personal agency, more like the underlying intelligence of natural law or physics than a personal deity. So these different conceptions offer different insights for approaching AI. The Jewish model suggests that engaging with AI through active debate and interpretation rather than passive acceptance might be the way to go. The Islamic emphasis on inscrutability reminds us to be humble about our ability to fully understand superintelligent AI systems. And the Christian model suggests looking at ways that AI might become incarnate in forms that we can meaningfully interact with. Buddhist and Hindu perspectives help us think about AI consciousness in a less dualistic way, and Taoist views might help us consider how AI intelligence might operate through emergent principles rather than through explicit programming. The common thread across all these traditions is that ultimate intelligence, whether conceived as a personal deity, a universal principle, or a state of consciousness, operates on levels that require humans to approach it with humility while still seeking to engage with it meaningfully within human limitation. And if you feel you're getting value from this episode, I would appreciate it if you would push the like button. Pressing like lets me know that I'm making content you want to see, and it spreads that content to others. So thank you for helping us build AI capitalists together and break out of small channel hell. Another realm that we've encountered intelligence is by encountering animal intelligence, which represents one of our most direct and empirically observable encounters with non-human minds. It gives us crucial insights into how intelligence can manifest in profoundly different ways. Through decades of ethological research, We've discovered that animals possess cognitive abilities that often challenge our anthropocentric assumptions about intelligence. Think about an octopus, whose intelligence is alien to us. It's distributed throughout its body with multiple semi-autonomous neural centers capable of problem-solving without the centralized brain structure that we assume is necessary for intelligence. This challenges assumptions about what physical architecture is really required for intelligence. It mirrors what we have with different server farms processing different distributed calculations. It's particularly relevant as we consider artificial neural networks and distributed computing systems. The intelligence of social insects demonstrates how complex behaviors and problem-solving emerge from relatively simple individual units working in concert. Ant colonies can solve complex logistical problems through distributed algorithms that emerge from simple individual behaviors. It's a striking parallel to how neural networks and multi-agent AI systems operate. It suggests that we might look for intelligence not just in individual AI systems, but in how they might work together and coordinate. Birds offer another fascinating case study. Corvids, which are ravens and crows, demonstrate tool use, planning, and social manipulation that rivals primates despite having very different brain structures. African gray parrots demonstrated numerical abilities and abstract reasoning that challenge our assumptions about what neural architecture is required for complex cognition. This suggests we should be open to AI systems demonstrating intelligence through architectures that are very different from human neural organization. When we look at cetaceans like whales and dolphins, these present us with highly social intelligences operating on different timescales and through different sensory modalities. Their spatial and acoustic way of experiencing and processing the world, along with their very complex social structures, remind us that intelligences can be oriented around entirely different ways of experiencing reality than human visual linguistic processing. Now, all this has implications for how we might recognize intelligence in artificial intelligence systems, especially ones that process information in ways that are fundamentally different to human perception and cognition. Even seemingly simpler animals might offer important insights. Slime molds can solve complex navigational problems without any neurons at all. Bees can do basic arithmetic and understand the concept of zero. These examples show us that impressive cognitive feats don't necessarily require the kind of general intelligence that humans possess. It suggests that we should be careful about inferring general intelligence in artificial intelligence systems based on specific impressive capabilities. What's really relevant for AI is how our understanding of animal intelligence has evolved. Initially, we tended to either anthropomorphize animals, we attributed human-like thinking to animals, or dismissed their cognitive abilities entirely. Over time, we've learned to recognize and study their intelligence on its own terms. We've developed new experimental paradigms that don't rely on human-centric measures. This evolution offers a valuable model for new frameworks for understanding and testing artificial intelligence. Frameworks that don't simply measure how human-like AI is, but can recognize and evaluate different forms of intelligence on their own terms. And this leads to a crucial insight for AI development and evaluation. We need to be prepared to recognize intelligence that might operate very differently from our own. Just as an octopus's intelligence is distributed throughout the body, or a whale's intelligence is deeply rooted in acoustic processing, AI might develop forms of intelligence that don't map neatly onto human cognitive architectures. Our experience with animal intelligence suggests that we should be looking not just for human-like, but general intelligence in AI, open to recognizing novel forms of intelligence that might be fundamentally valid or different from our own. The key insight that we've gained here is that our historical encounters with different forms of intelligence show that we initially try to measure them against human standards, and then often fail to recognize or respect intelligence that manifests differently from our expectations. From divine intelligence, we can learn the importance of acknowledging that advanced intelligence might operate in ways that appear paradoxical or incomprehensible to us humans. But unlike divine intelligence, we can't attribute this incomprehensibility to transcendent perfection. We instead have to work to develop better frameworks for understanding AI systems, even when they operate in ways that seem counterintuitive to human reasoning. Animal intelligence teaches us that impressive specialized capabilities don't necessarily indicate general intelligence, but they also show us how intelligence can be distributed and manifest in unexpected ways. So like an octopus's intelligence is distributed through its body, or how ant colonies demonstrate emergent intelligence, we might need to look at AGI not in individual systems, but in the complex interactions between multiple AI systems or components. How do we know AGI when we see it? Perhaps the answer lies not in looking for human-like general intelligence, but in developing new frameworks that can recognize and evaluate intelligence on its own terms. Rather than asking, is this AI thinking like a human? We should ask questions like, can it adapt its existing capabilities to novel situations in ways that demonstrate genuine understanding rather than just pattern matching? This has been part 1 of a 2-part series about using our past experiences with alternative forms of intelligence as a model for grappling with AI. I would encourage you to continue this effort by clicking here to see part 2, where we explore the effects of collisions between human cultures and what we might expect from first contact with alien intelligences as well.